Our project name is Steam Game Analysis. Our motivation is Steam is the largest digital game distribution platform in the world with a massive collection that includes everything from AA blockbusters to small indie titles. The great discovery tools can be super valuable for Steam. What's more, Steam has an open database which includes various game information like the number of players, the price of the games, and the rating of the games. We would like to analyze the information in database to show the relationship between the games and the players. In addition, we wanted to classify users and make recommendations to them according to their preference. Our dataset. We collect our data from this web page. Our dataset is a list of name, user behaviors with columns, user ID, game title, behavior name, on or play, value playing hours. We will use algorithm, key means, Gaussian mixture, collaborative filtering. We will use software, Fast and Spark. Data processing. Virtualizing duplication. See how much duplicated data you have. If you only have a couple duplicates or even more, you can just move on without worrying about them. See if there are any patterns in duplication. Finding, removing exact duplicates. Finding, removing partial duplicates. More than one record associated with the same observation, but the values in the rows are not exactly the same. Using the function from the script package by Scott. User classification. In the user classification, we think of three patterns. We are wondering if the clustering of the users will follow any of these patterns. The patterns are: if the user purchased more games, he will spend more hours on games. If the user played more games, he will spend more hours on games. If the user played more types of games, he will spend more hours on games. We use scatter plot to find the correlation between these behaviors. As for the result, only the second pattern, which is the games played and hours spent, has strong correlation. This lays the foundation for the clustering. In clustering, we tried two methods, key means and Gaussian mixture. In key means, we tried several key values, and we found that the value key equal to 6 comes out the best result. From the image, we can discover that the users are clustered into 6 groups, and the differences between each groups are the ratio of hours spent on games and games played. From Gaussian mixture result, we not only get 6 groups, but also we can separate hardcore player, those who buy a little game but spend a lot of time on those specific games, and the playboy player, those who played a lot of games but the total spend time is less. Then I will introduce the part of recommendation. The algorithm I use is collaborative filtering. Users who interact with items in a similar manner, for example buying the same game, share one or more hidden preferences. Users with shared preferences are likely to respond in the same way to the same items. Combining these basic observations allows a recommendation engine to function without needing to determine the precise nature of the shared user preference. Because I do not have the authorization to get detailed information like ratings from the users, what I can use is whether the user buying the game and the hours they spend on. So I have the following problems I have to deal with. First, whether I should contain the game which the user bought but did not play it. At first, I removed these games directly, but the precision of the outcome is not satisfactory. Only about 10%. This is because Steam sometimes has some discounts, and users will buy the game they want to play but have no time to do that. As a player, I think this does not mean they dislike it. If they indeed dislike the game, they can return the game instead of keeping it. So I jump these two columns and set the game time users buying but not playing to one. Second question is I have more than 5,000 games while some users only bought less than 10. It is difficult to recommend games for these people, and I made an experiment. As we can see, the precision becomes higher when I set the threshold that the least number of games a user have bought and to get a balance where most users can be recommended with a higher precision. I set the threshold to 20. So about half of the users can be recommended in the precision about 60%. If a player bought more than 60 games, the precision is 65, which can up to 90%. The last question is I should not treat the game time as game rating directly because different games cost different time to finish. For example, some games are more playable, like two users may spend more than 1,000 hours on it, while some indie game which tells a little story may only take 10 hours to finish. But this does not mean the former one is better than the latter one, so I should make a standard on each game themselves instead of the whole games. So I made a simple conversion formula to convert the time of the games to rating, which works like the following. X is game time divided mean time and Y is the converter rating. Here our rating system is from 1 to 5 and I set the mean time rating to 3. So if the game time is more than mean time, the rating is more than 3, and as long as the game time is 2 times or more than mean time, the rating will be 5. When the game time is less than the mean time, if the game time is 0, the rating will be 1, and I will increase when the game time increases. After solving 3 main questions, this is our outcome. I chose 80% of data to train and model, and left 20% data to test the precision. As we can see, the average precision is about 60%. Another thing is user and item biases, which are not necessary to build the system. However, I found including these parameters improved the recommender system. For example, we would expect some users play games at a faster pace than the others. Similarly, we also expect some games may have some trick to complete with less time. User can and item biases allow us to express these iterations in a statistical model. I expect there are systematic differences in how users interact with the games and how games are played. I also made a website for new users to make a procession, as I cannot get the data of a certain user from Steam dataset without a key. I should correctly enter the game name and play in hour of the game. This is very troublesome, so I only test it on my computer. Our conclusion is most users, the number of game played has strong correlation with number of hours played, making a recommended system with precision about 60% for more than half of users and make a web page for recommending to new users.